So in the last video we saw how to create classes and then how to construct some objects out of those classes. And then subsequently we saw how to then mutate those objects in order to have them represent specific instances. So we got my dog out of this being Ch11.2 at age 7 by first constructing a dog and then subsequently mutating in the main method the attributes of that dog. Now, a simpler pattern, rather than creating the object and then setting all the details, is to provide parameters to the initializer so that the initializer can set up the object as it should be. To do so, we just need to mutate our initializer here so that it has, refactor our initializer is the correct term, so that it has some extra parameters. So in this case, we want to give values for the name and the age, so just say name and age. And those now are values that need to be passed in when we construct our dog. So I'd say something along the lines of, what was it, Ch11.2, comma, and then we'll make them 7 still. Okay. Now we don't need any of these lines anymore. But now, what happens is the string Ch11.2 and the number 7 go into these extra parameters, so then the variable self still gets auto-populated by Python itself. When we call the dog class as though it were a function, that constructs a brand new object and passes that into self. And what we get as callers of this class is that we get to pass in the remaining values for the remaining parameters. So Ch11.2 goes into the second parameter, 7 goes into the third parameter. Okay, and now we just want to use those variables in order to initialize this object appropriately. So in this case, the variable name should go into self.name and the variable age should go into self.age. Now it's worth mentioning that these variable names, these parameter names here, don't necessarily have to be the same as the attribute names. I could have called this N and A, for example. It'd be a little bit less clear to see what those actually mean, but as far as the program's concerned, that's totally a valid operation. We're allowed to just pass in some variable and then use that variable's value to initialize the object. Okay, so it's common that you will have it where the parameter names match the attribute names because they're well-chosen variable names for a reason, so why waste them? But there's no confusion amongst the Python interpreter to distinguish between self.age and the local variable age. Okay, so if we want to know the value of the local variable age, it finds it from this parameter. If we want to know self.age, it has to go into this self object and then find out its attribute age. So those are distinct storage of values. Okay, one's inside the object, one's the local parameter or the local variable in this initializer function. All right. So initializer has a self parameter and some optional parameters. The self always has to be there, but we can pass in some additional parameters to make this initialization a little bit easier. So let's test this out. So this should give us the same result as we had before. So we get the name and the age print out, but notice we pass that information in. We didn't have to manually construct that object. The initializer now takes care of setting those values for us. Now, each object that we create from this class now is going to be its own instance of this class. It has its own scope, its own attributes. So for example, I could say another dog or other dog equals, and then create a brand new dog out of this the same way we did the first time. So dog, and then pass in a value for name. I'll call him Carl Barks, and some value for age, give it the value 1. And then we can just, for now, just print out these values as well. MyDog.name. And print mydog.age. Sorry, not mydog. I want otherdog.name and otherdog.age. So we have two separate instances of this dog class. So we have one object here that we called mydog, another object here that we called otherdog. And now if we run this, we should not surprisingly get both different dogs printed out. So we get the name and age of one dog, the name and age of the other dog. They're completely separate scopes. Notice they're using the same variable, .name and .age, but because we're asking for them out of different objects, so my dog.name and other dog.name, we get two different values. So other dog has its little box of variables, my dog has its little box of variables, and those are kept completely separate. They're not stored in the same spot in memory, even though they happen to have the same attribute names. Okay. So in order to represent the full attribute, you need both the objects as well as the attribute name. So not just the name. If we just said, for example, if I just said print name here, oops, save, run again, we get this error. There is no variable locally called name. So there's nothing inside main that's called name. If we want to get something that's called name, we have to go into one of the dog objects and then access that variable from there. All right. So each object is its own completely separate instance, and the values are not shared. Let's go to our slides here. So just like with lists, object variables refer to their data. So they're stored as references. Okay, so the thing that's actually stored inside my dog or other dog is not these boxes of variables, but rather a pointer to a specific location in memory where we can find those attributes. Okay. So this means we can create aliases as well, which was an issue we saw when we were dealing with lists. So we can have two variables that refer to the same object in memory. So for example, coming back here, I could print out, are these two dogs the same? So print my dog is, oh sorry, not my, let's do this. My dog is other dog. And then let's just print out my dog is other dog. So remember, the is operator does identity comparison. So the left half of this print is saying just print out a label. Comma says then print something else along with that label. And then we're going to print out the result of this operation. My dog is other dog. So the is operator says do an identity comparison and ask, are these two things pointing at the same space in memory? And we should get false because those are two completely separate instances of dog. Now, on the other hand, we can create an alias. So I could say something along the lines of my wife's dog is my dog. And then print out a same sort of thing here. So print my dog is wife's dog. And then ask my dog is wife's dog. Are these two things the same? And they should be, because this line here creates an alias. It says take what's stored in my dog, which is the reference to the actual dog object, and copy it into this variable. So if this was the address, let's say 123 Fake Street, now this is pointing at 123 Fake Street. Okay? Now they're computer addresses, so they're just long sequences of hexadecimal numbers, but you get the idea. Both of these things are storing the address of the object somewhere in memory. So my dog is wife's dog should come up true. Save and run. So my dog, other dog, those are different. My dog and wife's dog, these are the same. So creating an alias here says point these two things to the same target in memory. Now, when we did this with lists, we saw that there's a difference between identity comparison and equality. So we have, let's do this here, print my dog equals wife's dog. Okay. So we saw with lists, for example, these gave us different results, right? So long as two lists had the same values, then they were considered the same list as far as the equality operator was concerned. Identity-wise, they're stored in different locations, and that would tell us if they were completely separate instances, if they were aliases or not. But the equality just says if they look the same, then they're worth the same as far as that measure. Now, when we're dealing with objects, that is, say, our own custom objects, and this is very important to note, the default equality operation, so this double equals for objects, is identity comparison. Okay, so if we're using equals equals between two objects, if we haven't specified what that means, we'll see that in a later video, then by default, it does the is comparison. It has no way of determining are these two dogs functionally equivalent, so it says are they the same dog as its equality measure. So these two things mean the same thing by default. Using is between two objects is the same as using equals between two objects. For now, at least. We'll see ways of changing that, but by default, equals does identity comparison as well. So in this case, we should get true as well. There you go. And if we do that with other dog, we should get false. Now, as we've seen, we can create objects, we can mutate those objects, we can change the values. So it's worth pointing out here that once we've seen that we can create aliases, that's an issue because it was an issue with lists because lists were mutable. That's true of objects as well. So I can say, for example, my dog had his birthday today. My dog's age plus equals 1. And then I can print out wife's dog.age. So I can change my dog's age, but because it's an alias with wife's dog, that should change as well. And we can see my dog was 7, now my dog is 8. So it's gone up by 1. And that's true of both of those, both of the variables pointing at that object. So my dog.age. Okay, they both change because they're both pointing at the same object, and that object itself has changed. All right. Now, just like lists as well, when we pass an object into a function, we're also creating an alias there. So if a function mutates an object, then back outside of that function, anything referencing the object will also be mutated. So just like lists, we're dealing with references to data, not the data itself. Now, the advantage that we've seen so far is that we essentially just have reusable structures, right? We have the ability to construct these objects that contain multiple different kinds of data all in one place, and then if we want, we can create multiple instances of that. So it's really easy to specify what it is to be a dog, create all the variables, and then have as many dogs as we want, which is useful in some situations where we have lots of these simpler type entities, all with the appropriate attributes. So the objects that we've seen so far, just as containers of complex information, already quite useful and historically also quite useful, but objects in general are a lot more valuable once we encapsulate some behaviors into them as well. So let's talk about objects with methods. So methods are just functions that are represented inside of an object. So they specify the behaviors of those objects, and they're typically the verbs that you would associate with whatever entity you're trying to represent. So for example, a dog will bark or will fetch, so we could create bark and fetch methods that are associated with our dog objects. And we've seen methods before. So lists, for example, have the ability to list.append or list.pop. We've seen strings that have string.upper, string.find, string.replace, things like that. The syntax for constructing a method is pretty similar to constructing just a regular function, but is done inside a class. So somewhere inside our class definition, we have the keyword def here, which represents just a normal function definition, and then some method name that we want to specify, so bark or fetch or append. Now the main difference is that we have this required parameter. This is the self parameter. Now this is going to represent the object on which this behavior is operating. So which dog is doing the barking, which list is doing the appending, okay? And then if we want, we can optionally include additional parameters. So if we want to append some specific value, it would go into these additional parameters, okay? And now the behavior inside is just specified as a bunch of instructions, same way we'd create normal code, okay? So it's just a regular old function body. Now, if we want to use these methods, then elsewhere, outside of the class, once we've constructed an object, we just say object.method, so list.append or mydog.bark. And then optionally, for every parameter we added, we have to include an argument. Okay. Now, one thing is very important, though, is it's only for the optional parameters that we add. We don't include, however, a value for this self parameter. That happens automatically. So in the background, Python's going to turn object.method args into method, object goes here, and then all the args go into params. So let's see an example here. Let's go back to our dog and give our dog some behaviors. So inside our class definition, so underneath this class dog and indented over, we're going to say def to specify we're creating a method, and let's just create a bark method for now. Nice and easy. Def bark. Now, as I said, every method you create needs to have this self parameter. If you don't include it, when you go to run that, Python's going to try and include an object in there, and it's going to say, well, you didn't give me any space to put that object, so it's not going to work and it will crash. So def bark and then some parameter self that's representing the dog that is doing the barking, and in this case, it'll just print wolf, a real simple behavior. Now, later on, we want to use it, come down to our bottom of our main here. We could say something like my dog dot, and then instead of age or name, which are just values, we could say bark, which is a function. Now, bark doesn't take in any specific arguments. It just has this self parameter, which again is automatically populated. So what's going to happen in the background is it will get turned into, this might be easier to conceive of, dog.bark, and then my dog. Okay? Python's automatically going to turn it into that. So if we're typing mydog.bark, which makes sense as humans, we're saying my dog does the barking, Python's going to say, okay, well, the dog class has a bark method, and we're going to run that with this specific dog. So let's test this out, make sure it works, save, run our code, and when it gets to this line, it says woof. So when it gets to this line, it jumps up to this method, self is my dog, and it just prints woof. Doesn't actually matter what self is. All right. Now let's do a slightly more involved behavior here. Let's do some fetching as well. So def fetch. And now again, we need the self parameter, but we'll also include one other thing, stick. So this is going to be a Boolean argument that says whether or not we're actually throwing the stick. Now, the outcome of a fetch execution or a fetch behavior here is dependent, let's say, on the age of that dog. If the dog's too young, maybe it doesn't know how to fetch. So we'll say if self.age is less than 1, then self.bark and return false. So what this is saying is we need the age of a dog. Now the dog that we're currently fetching, or the dog that's currently doing the fetching rather, is going to be called self as far as this local method is concerned. So the only parameters in here that it can access are self. It can't access the parameters of, or the variables of main, because it doesn't know what my dog, wife's dog, or other dog are, because those are all enclosed in the scope of main. So what happens, as we saw down here, is when we run our function or our method, we're going to pass in the dog object itself, or rather Python is going to turn that into fetch with my dog as self. So if my dog is too young, then let's say less than or equal to 1, then nothing's going to happen. He's just going to bark, and that's going to be the end. If we want to have our dog bark here, we need to have access to the bark method that's stored inside a dog object. Self here is a dog object, so we can say dog.bark. This fetch behavior is going to run through the same set of instructions for every dog that gets passed in, but we'll get different results depending on their state. So let's see here. Let's do an elif. Self.age is greater than 15, so if we have a senior dog, then he just looks, kind of huffs at you and doesn't bother, so return false. Too old. And in all other cases, then we will return true if the stick was actually thrown, and return false otherwise, so we'll just say return stick. And maybe also self.bark. Okay. So our dog barks and returns true if the stick was actually thrown, otherwise not. And let's see how this can be used now. So along the lines of mydog.fetch, and say true that we actually threw the stick, and that's going to return true or false. So let's say got stick equals. So this is going to be true if my dog successfully fetched the stick, false otherwise, and then let's print out whether or not it worked. So print my dog returned the stick, and then just attach stick to it. And let's also do this for other dogs. So stick equals other dog.fetch. I'll say true as well. Actually, just call it got stick as well. And then we'll print that as well. Sorry, this should be got stick as well. Okay, my dog returned the stick, and this is other dog returned the stick. Okay, so we're going to call this fetch method. So again, this mydog.fetch true. In the background, Python will translate that to dog.fetch with my dog as self, and then true as the second argument. So if I can get that on the screen at the same time, not quite. Let's get rid of this. There we go. So dog.fetch with my dog and true. So my dog goes into self, true goes into stick, and then it walks through the behavior of this, asking information specific to my dog. So is my dog.age less than or equal to 1? Well, we saw down here when we printed that my dog's age was 8, so that's going to be false. going to come down here and say, well, what about mydog.age being greater than 15? Also false. So it lands in the else case. Mydog.bark, which we've already seen what that does. Mydog.bark just prints out woof. And then it will return the stick. So in this case, we passed in true, so we should get true back. And then the other dog will run through the same behavior. So other dog, I believe, is only 1 year old. So when we call other dog.fetch, it jumps into the same method, the same instructions, but with self being bound to other dog rather than my dog. Now, if self holds other dog, if we ask other dog.age is less than or equal to 1, well, other dog is 1, so that's going to be true. So we're just going to say bark and then just return false. So even though we threw the stick, we're not going to get that stick back. So notice using the exact same behavior, the exact same instructions, we're going to get different results based on having different states or different attributes in the two different dogs. So let's run this, see what happens. Okay, so here's where the fetching started. So mydog.bark and then mydog.fetch. And then my dog actually returned the stick, so that's great. And then we said other dog.fetch. Other dog barks, but was unable to retrieve the stick. Too young to figure out this silly game of fetch. So that's the end of this video. We've covered a lot here. So we've now seen that we can construct initializers that take in parameters and fill in the default values for us rather than having to manually construct each one of our objects. We can have our objects populated at construction time. And now we've also seen methods, so the ability to have state and behavior all collectively combined into one of these elements, like my dog or other dog. All right, in the next video, we'll go into more information about what it means to have an object, this encapsulation, and some of the worries that we need to have when we're dealing with objects. All right, I'll see you then.